again. Good afternoon. My name is Marina Deliani. I'm Trainings and Community Manager at Verimpact. Before we begin, I would like to thank you for taking the time to join us today in NEUROCLIMA Forum workshop. Before we start, a few reminders to please keep your microphones muted during the presentation to minimize background noise, and that the session is being recorded and will be shared with participants afterwards. If you have any questions, please use the chat box at any time during the session, and we will gather them for discussion. And with that, I will give the floor to Cristina Deliani. Thank you.
I would like to welcome you all. Today, this is one of the workshops in the series of the NEUROCLIMA Forum. The NEUROCLIMA project is an EU-funded Horizon project that promotes climate change adaptation for citizens and policymakers, and we have been developing many digital tools to promote this relationship. So today's workshop is part of the NEUROCLIMA Forum, which are the pre-pilot activities. Our pilot activities will be starting next year in 2026 in many countries, including Portugal, including Italy, Belgium, Cyprus, and Greece. So if you don't mind, we will be using your contact details to inform you of the pilot activities that will be happening next year. And today we have the honor to present two of the digital solutions, Lens and Bot, by two of the technical partners of this project. And with no further ado, I will be giving the floor to Tassos Kanelos from ITML, who will be presenting the NEUROCLIMA Lens digital tool. Thank you.
Hi, everyone. Thank you for participating. Let me quickly share my screen. And thank you, Christina, for the introduction. Okay, so hope my screen is visible. So I will be making a brief demonstration of the early prototype of the NEUROCLIMA Lens application, which is part of the overall NEUROCLIMA digital solution. And this application, NEUROCLIMA Lens, it is being jointly developed by ITML, my company, and also NovelCore, that is another partner in the project, with ITML working on the front-end user interface, while NovelCore focuses on the back-end functionalities, such as the search engine and the knowledge graph generator. So the NEUROCLIMA Lens application is essentially an application that provides a structured search user interface, which should be somewhat familiar to most people. We can use it to search through the curated data sets that have been incorporated into the NEUROCLIMA platform. And I need to clarify at this point that at this early release, the data sets that we have incorporated are rather limited and focus only on the agri-food sector, but we have plans to add more sectors in the near future. And currently, they include policy documents and scientific publication documents, but other data types, such as news, are planned to be added soon. So, for the sake of this demonstration, let's assume I am a journalist and I am preparing an article about how EU dairy production indirectly causes deforestation in South America due to the imported soy crops for cow feed. So I want to look for relevant material on this. So I use this search bar here and I type some search terms like deforestation, animal stock, soy, and maybe the common agricultural policy of the European Union. I also select a time range for the document publication and I hit search. Now, maybe as a journalist, I am investigating if some eco schemes coupled with policy support for EU-grown protein crops could help reduce deforestation risk. And basically, I'm looking for results that can potentially help me substantiate my report with evidence-based research and legislative provisions. So here I receive 50 relevant results in response to my query. Currently, they are sorted according to their relevance to the search topic, but I can also sort them according to the publication date to find the most recent ones, for example. Now, the icon here at the left of its result represents the type of document. For example, this is a policy document, and this is a scientific publication. I can open each of these results to see a preview from the document that it corresponds to, and essentially its result is a segment of one of the documents in the NEUROCLIMA datasets that was found to be relevant to the search query. The title here, it's the title of the originating document that contains this segment. So this is the segment that was found, let's say, to be most relevant. And we can see here some more information, like some tags and keywords, the publication date, the publisher, the authors, and for example, the authors might be useful if I'm a journalist. Maybe it can help me identify authorities or relevant actors in the field to plan some interviews. We also have access to the original document from here, so I can access the PDF and look into it for more details or to find the context from where this segment, let's say, was found in. And if I scroll further down, you can see these results are organized in different pages, so I can browse through them. And at the bottom here, we have a knowledge graph where the search results are represented. Basically, they are the nodes in this graph, and the connections between the nodes correspond to the associations between the search results. So this, we expect that it can help me understand how the information is organized, how various pieces are related to each other, and potentially see if there are any clusters of homogeneous information that I can dig further into to discover more relevant information. I need to note here that this is just a mock-up image, so it's not functional. We are working on this independently, and we are planning to integrate this functionality soon in the interface of Lens. Now, if I scroll further up, here at the left, we have a list of filters that I can use to narrow down the search. For example, select some domain key areas, the publication date, the geographical area of reference, or the document type that I am interested in, like policies and news. Now, if I click on a particular result, I can see a more detailed view of the result with some additional information that we are considering to present, such as the citation information here or options to share the result on social media. This about covers the current status of the implementation in terms of features for the Lens application. But yeah, I have some mock-ups of some other features that we are planning to integrate. For example, here we plan to support bookmarks, where I, as a user, I can select some of the results and store them as bookmarks and organize them into lists so that I can review them at a later time. And another feature is the possibility to allow users to provide ratings to the viewed documents and also leave comments in the form of discussion threads. And we expect that this can help other users better evaluate the presented information. And in the future, it can potentially also be used to improve the operation of the search engine. And I will stop here. This is what I had to present. Thank you very much for your attention.
So do we have any questions for Tassos on how this works? I think that this is a fantastic tool. If you're a researcher, if you are a journalist, a student, or a concerned citizen, it gives many functionalities, and we have taken care a lot as regards the all the data sources that this tool is aligned with and takes data and information from. And I will be giving the floor to Odysseas because if you open the chat, there's a survey. This is an interactive session, so during the 40 minutes that we will be together, you will be asked to answer some of the questions that we have prepared for you. So Odysseas?
Yes, hi everyone. I have just posted the link to the chat, so you can just click and see. We have a few questions that we'd like you to answer after Tasha's presentation. I see that results are coming up.
Excellent, thank you. I think that you have enough time to answer questions. Before we go to Prasasti from the University of Oulu, who has been creating the NEUROCLIMA bot, which is another of the digital tools that we have prepared that helps understand climate change adaptation, but also brings citizens closer to policymakers and promotes research and promotes access to resources that have to do with climate change adaptation. So Prasasti, the floor is yours.
Thanks, Christina. I'll share my screen. I'll start with a short presentation, then go to the live demo. Okay. Hello, everyone. I am Prashasti Balasubramanian, researcher at University of Oulu. I'm going to present NEUROCLIMA bot. NEUROCLIMA bot is an AI-powered conversational agent designed to enhance the decision-making and raise awareness on climate change adaptation. It allows a user to search, summarize, and explore the climate data in multiple languages, all through natural language conversation. And we are using combined knowledge graph reasoning and dual rack strategy to ensure a reliable and evidence-based insight while significantly reducing the hallucination, which is one of the main challenges nowadays conversational agents are facing. Ultimately, it powers the policymaker, researchers, and citizens to collaborate more effectively and turn data into action for sustainable future. So this is just a diagram. This shows what happens behind the scene. Climate data is collected via MinIO and some Flax background, and we are using AI modules. And we use a RAG layer, generate the context-aware answers powering the conversational bot. The entire system runs smoothly across a cloud and container environment. It basically helps in scalability and reliable performance. And this is a core layer, basically the main intelligence part of the chatbot. Just to have a reference, it's an AI-based indexing and contextual embedding to retrieve the key data. It uses multimodal RAG router, merges graph data and LansDB, which contains summaries and the graph information, and also Milvas, ensuring precise and meaningful responses that drive adaptive climate actions. So this is the algorithm when a user asks for a question, basically. This algorithm basically generates a response, and a query comes in it. It identifies the key entities, key information, relationships, summaries from its knowledge base. It prioritizes and re-ranks the response and most relevant information to create clear and context-aware response, improving continuously through interaction with the user. So the chatbot actually learns from its interaction with the user as well. So this is a video. I'll just run, and then after that, I will go for a live demo as well.
Hello, everyone. Today, I'm showing you NEUROCLIMA, our AI chatbot built for climate conversations. This project gets funding from the European Union and helps people understand climate topics better. Here's the main page. You can see our bot logo on the left side. Users have several options to customize their experience. First, you can change languages. We support 4 languages: English, Italian, Portuguese, and Greek. This makes our bot accessible to people across Europe. Next, users pick their reading level. We have 2 modes. Easy reading uses simple words that anyone can understand. Advanced reading works better for experts and researchers. We added a feedback form so users can tell us how to improve the bot. This helps us make the system better over time. There's also a user dashboard. It shows interesting statistics like which languages people use most. Users can see popular questions, trending documents, and common keywords. At the bottom, we have privacy information and logos from our partner organizations. This work was developed by the Future Computing Research Group within Ubiquitous Computing at the University of Oulu. Let me ask a simple question to show how it works. You can see the loading animation while the system processes your question. This gives users feedback that something is happening. Here's our answer. The system found that 91.3% of the information matches your question. In the reference section, you can see source documents ranked by how relevant they are. Users can click these links to check the original documents. This is important because AI systems can make mistakes. Users should always verify the information. This answer includes social tipping point analysis. Our system can identify when climate topics relate to social changes in communities. Let me continue the conversation by asking about agricultural organizations. When we ask follow-up questions, previous references get hidden to keep the interface clean. Users can still expand them if needed. This design keeps conversations clean. You can see the response loading with its animation effect. Looking at the right side, the system displays social tipping point information relevant to your question. Right underneath, you'll find an Explore button for accessing the interactive knowledge graph. Here's our knowledge graph visualization using Microsoft GraphRag. You can see all the entities and their relationships. This helps users understand how different climate topics connect to each other. Users can expand this to full screen or switch to 3D view for better visualization. Every response comes with 4 useful buttons. You can copy the text, listen to it using our text-to-speech feature.
The Food and Agriculture Organization, FAO, plays a crucial role.
Or give feedback with the like and dislike buttons. The system has automatic session management. You can see the active session counter in the header showing 10 minutes. This timer only counts down when users aren't interacting with the interface. A pop-up notification appears in the final minute as a warning. After timeout, users get redirected to the home page and their session data gets cleared for privacy. Refreshing the page will also bring you back to the main page. Now let me show the admin dashboard. This is where we manage the system. Here you can see all processed documents. Each document shows its name, storage bucket, and processing status. We can see if we've created chunks, summaries, and knowledge graphs for each document. Admins can process documents individually or process entire buckets at once. The system logs show all activity. We also have health monitoring that tracks each system component. In the feedback analysis section, we review user like and dislike count. Administrators can navigate to Langfuse to see comprehensive traces. This shows exactly how the system works through each question and builds its responses. This section displays every question users have asked the bot, both conversation starters and follow-up messages. Clicking on any query reveals a step-by-step view of how our backend services processed that question. You can see what data went into each service, what came out, and exactly how long each step took to execute. NeuroClimaBot empowers informed decisions with fast, evidence-based answers and real-time context-rich insights for climate adaptation. It's a smart, multilingual assistant, making climate information accessible, actionable, and reliable. Hello, everyone.
So now I'm going to run a use case. You can see this is a use case. A policymaker is using the NeuroClima bot to assess the climate risk to agriculture across Southern Europe, identify relevant EU adaptation programs. The bot is supposed to provide a concise and data-driven insight from trusted sources like IPCC, EEA, and helping connect scientific evidence with policy actions for climate resilient agriculture. I'll just this is the bot interface, live interface. I hope it's visible. Then I have crafted some questions as well as per the use case. I'll just. Okay. You can see it takes a little loading time because heavy LLMs are running behind it, which takes some time to process the queries and get the response. And it's also running the algorithm that generates the response, basically. Okay, just give me a second. Okay, so you can see the response is there, and there is a voiceover, which
In Southern Europe,
so you can switch it on, and we have made it as female sound as of now, and there are references over here. You can see the social tipping point. This is one of the point which I'm going to explain in the next section, how we are developing and integrating the social tipping point back into our solutions. And I can, maybe I'll do a follow-up question on this. I've already prepared the question, so let me see. You can see as in the video, the reference is getting hidden. This basically helps, and there is a session active also, because every 10 minutes the session getting expired, because it's not a profile-based chatbot. It's basically a session-based. It helps to keep it in GDPR compliance, basically, and the feedback and dashboard is always shown in the like the UI. Okay, you can say it gives a similar response with the references. We can check the references as well. It automatically opens up. Go back here. Let's just see the explore. So you can see the knowledge graph is there. I can make it a 3D and full screen as well. Okay. So this basically helps to get some informations like this. Can go inside and search accordingly, actually. So these are some kind of views you can make use of it. Then the documentation is also highlighted over here if you see. So this is one feature. So this is and the dashboard, which basically shows what is the language and total number of queries that has been processing, some statistics on the queries, and like the word cloud, what are the combinations and questions have been asking, and all those things. And there is an admin dashboard that we have not included here because it need special access also, which basically helps in a lot of other analysis as well, which was showing in the video. Now I'll go back to the presentation. Okay. So I was showing the social tipping point, which is the next thing which I want to showcase here. So in this slide, we will focus on social tipping point moments when small collective actions can trigger major shifts in society, like how the society adapts to the climate challenges. So these are like social challenges, not physical ones, involving shifts in behavior, policies, or mindset that spread quickly once enough people or organizations are involved. In climate adaptation, this happens when communities, policymakers, scientists, and business align around shared goals, such as when data, public awareness, and policy come together. So NeuroClima helps to identify where such collaboration can spark wider, lasting change and guide the society towards a greater resilience. So that's some glance on like what a social tipping point, how we are going to use in our solutions. So this basically shows how we try to integrate social tipping point in our solutions. We developed STP document analyzer, which I am going to show next. It is a backend framework with multiple fine-tuned LLMs. So as part of data collection to fine-tune these LLMs, the consortium task force collaborated to design and create STP examples for training these models. So basically, this slide show what are the things we have gone through while the design stage. Using this foundation, the system is now capable of automatically detecting and extracting social tipping points from the resource documents in our data lake. This basically helps in identifying where the collective actions can trigger broader societal changes. So a little more in the design stage, how we come up with these examples basically to operationalize the concept of STP. The task force basically defined a clear set of qualifying factors on the literature. These include the presence of environmental problems with recognized societal consequences, a shared social awareness of those problems, and a collective understanding of their causes and effects. In addition, there must be an expressed perception of the need or for change and a socio-political demand for explanations and actions. So based on these criteria, we partners collaboratively created the initial data set for training of the LLMs, and it basically helped to develop the pipeline, LLM training the LLMs and all. And further, I'm going to show a little more details on that. So this is just the pipeline, how we developed it. This diagram basically shows the backend pipeline just to have an information, how we detected the STP from the documents. It begins with the data preprocessing and hybrid chunking and followed by an AI-driven module, which have multiple modules like classification, rephrasing, and generation of qualifying factors. The resulting social tipping points and factors are actually basically indexed in our databases, which helps in basically it can be accessed via APIs. So there is an easy integration with the NeuroClima digital solution interfaces, and the main interface solutions which is using that as Lens and Bot. Bot, I have already showed you how we are using in the UI the social tipping points. So it's basically a complex pipeline basically which runs in the backend. So we created an admin dashboard that basically helps to process, analyze the documents step by step, thereby easy detection and extraction of STPs can happen. I'm going to show you a video on that.
The STP Document Analyzer is a web application that runs a multi-stage pipeline to extract social tipping point data from climate-related documents. This project was developed under the Future Computing Group at the University of Oulu, Finland, as part of the NEUROCLIMA interface. The application features a sidebar which provides configuration for object database, chunking, processing models, and vector database. User can configure these parameters on the startup or before each stage. After initializing object database connection, you can choose the documents you want to be processed. You can choose multiple documents or remove the documents you want to exclude from processing. The interface provides an estimated processing time for the selected documents across all stages. Users can view the coverage of processed documents and the titles of those not yet processed. Once documents are selected, they can be processed in the chunking section, where they are divided into coherent chunks. The interface displays content for each individual chunk. Next, in the classification section, chunks are labeled as STP or non-STP with confidence scores, which are shown in the interface. After that, the STP chunks move to the rephrasing section, which uses an LLM to transform each chunk into a self-contained structured piece. Next, we move to the qualifying factor generation stage, where an LLM generates 5 predefined factors for each chunk, along with a confidence score and justification for each factor. Next, in the results section, the interface presents metrics such as STP distribution, model confidence, qualifying factor distribution, and the number of chunks created per document. We can filter chunks based on prediction label, exclusion status, or just show the flagged ones. We can also review flagged chunks with poor qualifying factors or rephrasing in detail. These chunks can be manually verified and excluded if they do not meet the required criteria. After reviewing the data in the results section, we move to the vector database to generate embeddings and store them in Milvus. Here, we can also test the connection status and view database statistics. The final section is the Export tab, which allows us to export each phase's results into a CSV file for testing, comparing models, and improving individual phases. The STP.
So that's all from my end. If any questions, please let me know. Yeah.
Thank you, Prasasti. It has been, I mean, I'm very much impressed every time you present the bot and the functionalities it has. Do we have any questions? So there's the chat function, there's the Q&A function you can use to ask Prasasti or Tassos any questions.
I just want to remind the audience that we have the second survey regarding the NEUROCLIMA bot, so we would appreciate your answers as you did last time. It's open. You can find the link in the chat box, so please vote.
I don't know, Alicia, have people started voting?
Yes, we have.
Okay,
We
excellent.
already have the results, but
Excellent.
we would appreciate more.
And while people are voting, participants are voting, I'd like to announce that on December 9th, we will be having the final NEUROCLIMA Forum workshop for this year. We will be showing NEUROCLIMA Learn and Play, the two functionalities for teachers, students, both at the tertiary education, but also in the primary and secondary schools. So I don't know if we have any questions or if the voting is ending now.
We could use a few more votes, but we are okay. I mean, people have already voted, most of the people.
So I'm urging you to continue and finish voting for this session. And we're very much looking forward to seeing you in the next workshop, but also in the pilots that we will be doing in 2026. If you're in Portugal, Greece, Italy, Belgium, Cyprus, you're more than welcome to participate. We will be having online and in-person webinars and workshops. We will also be sharing material in Greek, Portuguese, I think French, if I'm not mistaken, in Italian. So And with that, I would like to give the floor back to Marina to close off the workshop.
Thank you, Christina. Thank you to our fabulous speakers, our partners, for showing NeuroClima bot and NeuroClima lens. As always, this session has been recorded and you will receive the recording session. Please stay connected with the NeuroClima Forum, either through our website or our social media platforms. Thank you for joining us. Please don't forget about the upcoming webinar on the 9th of December, and we're looking forward to seeing you then. Thank you very much. Have a lovely afternoon wherever you are.
Thank you. Bye-bye.
Thank you, everyone. Thank you very much.
Thank you. Bye.
Thank you. Bye-bye.
Thank you. Bye-bye.